Today's lesson is on system of equations, solving a system of equations with graphing. We'll be looking at how when we solve a system of equations, we can have one solution, no solution, or infinitely many solutions. The definition for a system of linear equations is two or more equations that work together. The solution of the two equations is the ordered pair that makes both equations true at the same time. There's three possible solutions in a system of equation: one solution, no solution, or infinitely many solutions. In one solution, you'll see that the lines intersect at one point. In these two equations, when they're graphed, you'll see that they cross at 2, 5. There is only one ordered pair that satisfies both equations when there is one solution to this system of equation. This is the point where the two lines intersect. Let's look at an example with graphing. If you recall, we find the slope and the y-intercept to graph. So if we start with the y-intercept, b equals 1, we put a point at 0, 1. Next, we use the slope to find our next points. We go up 2 over 1, up 2 over 1, up 2 over 1. And we see that we can graph a line going through these points. Let's graph the next line. Negative 3x plus 6. We'll put our point at 0, 6. That's our y-intercept. We're going to use our slope to find our next points. Down 3 over 1, down 3 over 1. And we end up with points like this. Next, we graph our line, and we see that there's the point where these intersect is right here at 1, 3. So the two lines intersect at this point. Therefore, this is the solution to this system of equations. The solution is the ordered pair at which both lines intersect. Sometimes we have a system with no solutions. Parallel lines show that they will never intersect. These lines have the same slope, but a different y-intercept. No intersecting points, and they have the same slope. This is what we need to look for when we see the equations. If we find two equations have the same slope and a different y-intercept, we know that they are parallel and therefore have no solution. Let's look at an example. Here we have 2x plus 1 and 2x plus 6. In the first equation, we're going to graph our point at the y-intercept of 1, 0, 1. Up 2 over 1, up 2 over 1. Draw our line, and we have our line drawn. Next, we're going to plot a point at the y-intercept for the second equation at 6. Notice we go up 2 over 1, and we have our next point, up 2 over 1. We can also go down 2, back 1, and find another point. Now we see that our lines are parallel. The two lines are parallel. They have the same slope, but different y-intercepts. They never intersect. Therefore, they have no solution. In this example, we'll look at infinitely many solutions. See that both equations are identical. Y equals negative 4x minus 3 and y equals negative 4x minus 3. They have the same slope and the same y-intercept, so they are the same line. The equations for the lines are identical. All of the ordered pairs on the line are a solution for both equations, so no matter which point we select on the line, it will satisfy both equations. If we graph this, we'll plot at 0, 1, up 2 over 1, up 2 over 1, and plot the second line, up 2 over 1, and we get the exact same line because the points are exactly the same. The two lines are identical, the same slope, same y-intercepts. All points on the lines are solutions. In summary, a system of equations is two or more equations working together. The solution of a system is the ordered pair that makes both equations true at the same time. There's three possible outcomes for this system of equations. One solution, when the slope and y-intercept is different on both equations, the lines intersect at one point, and only one ordered pair will satisfy both equations. We can have no solutions. When the slope is the same on both equations, the lines are parallel, and they will never intersect. Or we can have infinitely many solutions. When the slope and the y-intercept are the same on both equations, the lines are identical, and every point on the line will satisfy both equations. That's all. I hope this was helpful.